Hey, welcome back. We're here formalizing what was going on with our confidence intervals. So let's talk you through those. So, two important ideas to go through. One, we're tweaking something we did yesterday. Okay. So, and then when you interpret a confidence interval, we're going to say if we take many samples and calculate out the confidence interval for each, about blank percent of them, so whatever you decide to do, will capture the true proportion of times Mr. Hayes screws up in class, true proportion of ducks to non-ducks in Mr. Hayes' room, that type of thing, okay? We also have the margin of error. Now, we know what the margin of error is. We calculated that out yesterday. We're doing a couple things here. What ends up happening here as the confidence level increases, the margin of error is going to increase. It's the only way that you can do it. If you want to capture more, you have a better chance of capturing the true proportion, you need to make the net wider. It's the only way that we'll do it. So that means that our margin of error is going to go from small to large. Now, the question is, you don't want to have a really large margin of error because that's going to be annoying. So how do we make that margin of error go down, make it narrower? We have to increase the sample size. We could reduce the confidence level, but then that just is going to make us look funny, make us look like we don't know what we're talking about when we miss it more. So your best options are, we know that when we increase the confidence level, so we're more accurate, the margin of error goes up. So to counteract that, we really should be increasing the sample size as well, so we can tighten up the margin of error as much as possible. Here's your check your understanding. Physical education teacher at a large high school wants to estimate the proportion of students at the school who can do a pull-up. He selects a random sample of 30 students from those who are available after school for sports practices. He records whether or not each student in the sample can do a pull-up. He has 90% confidence that the interval from 0.418 to 0.715 captures the true proportion of all students who can do a pull-up. So first thing, pause it here, go through the questions, and then come back and check your work. Okay, so if the confidence interval on this, we are going to talk about what the confidence interval is. The confidence level is when we talk about what the percentage means. So in this case here, we are 90% confident. Can you tell we usually do 95%? We are 90% confident that the interval from 0.418 to 0.715 captures the true proportion of all students that can do a pull-up. Now, what does that mean to be 90% confident? It means this. If we take many samples and calculate out a confidence interval for each of those, about 90% of them will capture the true proportion of students who can do a pull-up. All right? So when I ask you to do the confidence interval, you're going to say the first one. When I talk about confidence level, you're going to do the second one. Now, how is it going to be differ instead of doing a sample size of 30 if we did a sample size of 200? Well, we know that the sample, larger the sample, the smaller the standard deviation is going to bring it in, which is why I said it would be narrower, since increasing the sample size decreases the margin of error. Likewise, if we decrease the confidence level to 80%, so again, if we did this many times, we'd only capture 80%, the proportion 80% of the time. You would say it would be narrower, because since we're reducing the confidence, that means we need a smaller net. So again, since the decreased confidence level needs a smaller margin of error. Last two things. First one's the answer. The second one is kind of a sum-up statement. Describe one potential source of bias. Under coverage. We're only talking with athletes after school. That's no good. So we're only really be able to talk about this proportion that he's getting is really only good for students who stay after school for sports who are in season at that point, right? So we're not getting anybody who doesn't participate in the after school sports then. Now, here's the important thought. Margin of error only covers sampling issues, okay? So any variability from the sampling, margin of error is going to catch. Bias is not covered in margin of error. Bias, such as undercoverage, non-response, response bias, etc., aren't accounted for in that. We're going to talk about that, but a lot of that has to happen in the design. All right? So anyway, that's this. We will see you when we're going to talk about how do we come up with what the actual margin of error should be. And I'll see you next time.